The cosine and sine functions allow us to model the horizontal and vertical components of certain angles. But let's clarify what we mean by that. So consider the angle I have shown. The initial ray points in the 3 o'clock position, and this angle has a measure of 0.7 radians. The terminal ray of this angle intersects the circle that we centered at the vertex of the angle at a certain point. For ease of reference, we'll call this point the terminal point, because this is where the terminal ray intersects that circle. This terminal point has a location relative to the center of the circle. By that, I mean this terminal point has some distance to the right of the center of that circle and some distance above the center of the circle. If we measure these distances in, say, centimeters, and then we change the size of that circle, those distances in centimeters are going to change. However, if we measure those distances in radius lengths or in radii, those distances are actually fixed. So in this diagram, that terminal point is actually 0.644 radii above the center of the circle and about 0.765 radii to the right of the center of the circle. And notice that these units are radii. It's not centimeters, it's the radius of that circle. So when the size of the circle changes, the radii or the radius length is going to change as well. So to represent these distances, we use the cosine and sine functions. In this case, cosine of 0.7 represents this horizontal distance to the right of the center of the circle, measured in radii, and sine of 0.7 represents the terminal point's vertical distance above the center of the circle in radii. So the 0.7 in both of these cases comes from the measure of this angle that we're looking at. If the angle's measure changes, we can change the input to these functions, and the outputs will still give us the same quantities values. So the sine and the cosine functions are always going to output these kinds of values, but if we change the measure of this angle, we just change the input to these two functions. So, given an angle whose initial ray is in the 3 o'clock position, and any circle centered at the angle's vertex, if theta represents the measure of the angle in radians, then cosine of theta will represent the terminal point's horizontal distance to the right of the center of the circle in radii, and sine of theta will represent the terminal point's vertical distance above the center of the circle in radii. Now that's kind of a mouthful, so if you're like me, you might prefer just to imagine this with a diagram. So if theta is our angle measure in radians, swept out from the 3 o'clock, then cosine of theta gives us that horizontal distance in radii, and sine of theta gives us the vertical distance, again in radii. Keep in mind that the sine and cosine functions both take a number of radians swept out from the 3 o'clock position as their inputs, and both output a number of radii, or radius lengths. And another thing to keep in mind, if the output of the cosine function is negative, that terminal point is actually to the left of the center of the circle. And if the output of the sine function is negative, the terminal point is actually below the center of the circle. Let's look at an example using the sine and cosine functions. We have this diagram here, and we want to know the coordinates x, y of this terminal point shown in purple. So what we see is an angle whose vertex is at the origin. We see that the angle sweeps out 5.2 radians from the 3 o'clock position, and this circle that we have centered at the angle's vertex actually has a radius of 3 units. So the radius in this case is 3 units. We'll just go ahead and write that up here so we don't forget about that. This terminal point has some distance to the right of the center of the circle, which will be its x-coordinate, and some distance above the center of the circle, which will be the y-coordinate of that point. So this distance to the right of the center of the circle, we know that that distance is cosine of theta, or cosine of 5.2 radii. However, the radius of the circle is 3, so that distance in our standard units is actually 3 times that cosine of 5.2. So our x-coordinate in this case is 3 times cosine of 5.2. And 3 times cosine of 5.2 is roughly 1.406. Now in a similar way, that terminal point's distance above the center of the circle is represented by sine of theta, so sine of 5.2, and that's a number of radii. So sine of 5.2 tells us the terminal point's height above the center of the circle in radii, but we know that the radius of our circle is 3 units, so that actual distance in our standard unit is 3 times the sine of 5.2. So 3 times sine of 5.2, and that'll give us the y-coordinates of this terminal point. And 3 times sine of 5.2 is roughly negative 2.65. So it appears that our coordinates of this point, so the coordinates xy, are about 1.406 and the negative 2.65 for our y-coordinate. Now we could actually be more precise with this. If we want to represent exact values, we would write xy is equal to 3 times cosine of 5.2 and 3 times sine of 5.2. We can always plug these two expressions into our calculator to find an approximate value for those things, but this is actually a more exact way of writing the coordinates of that point.